Revision of squares and square roots. Square numbers or perfect squares. Square numbers are the numbers when you multiply the number to itself. That means whenever you multiply 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5. So you are multiplying the number to itself, then you get a perfect square. That means 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, and so on. A square number can also be defined as if a natural number m is expressed as n square, where n is also a natural number, then m is called as a perfect square. See, if I assume all these perfect square with a variable m, it goes to infinity here, and here also it goes to infinity. So this is n square. So if you write a natural number m can be expressed as n square, where n is also a natural number, then m is called as the perfect square. Let us now discuss the properties of square number. So here in this column I have written down all the numbers, and here I have written down the squares of the respective numbers. So let us observe the units place of the square number. What all numbers are present in the units place of a square number? So units place of a square number has got 0, it has got 1, it has got 4, 5, 6 and 9. So a perfect square, it ends with 0, 1, 4, 5, 6 or 9. Which all numbers are missing here? You can see 2 is not there, 3 is not there, 7 is not there, and 8 is not there. That means if the number ends with 2, 3, 7 or 8, that means it is definitely not a perfect square. But if a number ends with 0, 1, 4, 5, 6 or 9, then it may be a perfect square or it may not be a perfect square. For example, if I give you 301, this ends with 1, but it is not a perfect square. Similarly, 409, it ends with 9, but it is not a perfect square. So if the number ends with any of these numbers, then it may be a perfect square, it may not be a perfect square. Now let us see some more properties. Here, if a number ends with 1 or 9, here also the number 11 ends with 1, here 19 ends with 9, then the perfect square ends with 1. You can see 1 square is 1, 9 square is 81, it ends with 1. 11 square is 121, it ends with 1, and 19 square is 361, it ends with 1. So if a number has got 1 or 9 in the units place, then the square number has got 1 in the units place. There is one more property here. If the number ends with 2 or 8, 2 or 8, then the perfect square ends with 4. Perfect square ends with 4. So here 2 square is 4, 8 square is 64, ends with 4. 12 square is 144, 18 square is 324. So 144 ends with 4, 324 ends with 4. So if a number has got 2 or 8 in the units place, then the square number ends with 4. Now let us take 3 and 7. If the number has got 3 and 7 in the units place, then the square number ends with 9. 3 square is 9. 7 square is 49. You can see the number and perfect square ends with 9. 13 square is 169. 17 square is 289. The perfect square here ends with 9. If the number ends with 4 or 6, then the perfect square ends with 6. You can see here. For 4 it is 16, for 6 it is 36. It ends with 6. 14, 196, 16, 256. So the square numbers they are ending with 6. So if the number has got 4 or 6 in the units place, then the square number ends with 6. If the number has got 5 in the units place, then the square number ends with 5. For 5 it is 25. Perfect square ends with 5. For 15 it is 225. So perfect square ends with 5. If a number has got 0 in the units place, then the perfect square also ends with 0. Now you see here one more property. All the squares of odd numbers. 1 square is 1. 3 square is 9. 15 square is 225. 19 square is 361 and so on. That means if you take the square of an odd number, it is going to be always odd. So square of an odd number is always odd. Similarly, square of an even number is always a even. You can see here 8 square is 64, 16 square is 256, 20 square is 400. So square of an even number is always even. Let us now discuss here one more property of square number. If the number has got 1 0, then the square number has got 2 zeros. If the number has got 2 zeros, then the perfect square has got 4 zeros. If the number has got 3 zeros, then the perfect square has got 6 zeros. That means in perfect square you have got double the number of zeros than you have in number. So we can say that a square number always has even number of zeros. A square number always ends with even number of zeros. Some more interesting patterns. Adding triangular numbers. So these numbers 1, 3, 6, 10, 15, they are triangular numbers. So if you add consecutive triangular numbers, say 1 and 3. So 1 plus 3 is 4. That is the perfect square of 2. 3 plus 6 is 9. That is a perfect square of 3. 10 plus 6 is 16. This is a perfect square of 4. 10 plus 15 is 25. That is perfect square of 5. So whenever you are adding two consecutive triangular numbers, you are getting a perfect square. Numbers between square numbers. So let us find out if there is a perfect square, say n square, and one more perfect square is n plus 1 whole square. So how many non-perfect square numbers are there between these two perfect squares? 2n. Let us understand this with the help of example. Say here I take the value of n as 3. So 3 square. n plus 1 will be 4. 3 plus 1 is 4. So 4 square. So 3 square is 9. 4 square is 16. How many non-perfect square numbers are there between? 10, 11, 12, 13, 14, 15. So there 16 is a perfect square. So you have got 6 non-perfect square numbers between two given perfect square. That is 2n. What is n? And we have taken it here as 3. So 2 into 3 is 6. So this is how we use this formula to find out non-perfect square numbers between two given perfect square numbers. Adding odd numbers. If you had all the odd numbers starting from 1, then you will always get a perfect square. The first odd number is 1. So 1 is 1, that is 1 square. You add the first two odd natural numbers, 1 plus 3, that will give you 2 square, 4. If you add the next three odd natural numbers, 1 plus 3 plus 5, that is 3 square, that is 9, because you are adding 3 odd numbers. When you add 5 odd numbers starting from 1, 1 plus 3 plus 5 plus 7 plus 9, since you are adding 5 odd numbers, that is 5 square is 25. If you add all these numbers, you will get 25. 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16, 16 plus 9 is 25. So like that we do it. So sum of first and odd natural numbers is n square. That means all the perfect squares, they are the summation of all odd numbers starting from 1. That means if you start removing the odd numbers from a perfect square, then you should get a 0 in the end. If you don't get it, that means it is not a perfect square. It is like doing the reverse. From 25, if I remove 9, then I remove 7, then I remove 5, then I remove 1, 3, then I remove 1, then you will get answer as 0. In how many steps you have reached? 1, 2, 3, 4, 5. So that's how we find out the square root of 25 here as 5. A sum of consecutive natural numbers. We can express the square of any odd number as a sum of consecutive natural numbers. For example, let us take 7 square. The 7 is an odd number and the square of 7 is 49. So 49 can be expressed as sum of consecutive natural numbers. How are you going to find out? 7 square minus 1 divided by 2. So 7 square is 49. 49 minus 1 is 48. 48 divided by 2. So what will you get here? 24. And next one you will get it as 7 square plus 1 divided by 2. So that is 50 divided by 2. That is equals to 25. So 49 can be expressed as 24 plus 25. Like this we find out. Let us take one more example. Say 9 square is 81. So it can be expressed as sum of 9 square is 81 minus 1 is 80 divided by 2 is 40. And 81 plus 1 is 82. 82 divided by 2 is 41. So 81 is expressed as summation of two consecutive natural numbers 40 and 41. This method you can do it for square of any odd number. Now let us take product of two consecutive even or odd natural numbers. So here we let us take 11 into 13, two consecutive odd numbers. So 11 can be written as 12 minus 1 and 13 can be written as 12 plus 1. So this is 12 square minus 1. Let us take two even numbers 14 into 16, two consecutive even numbers. So 14 can be written as 15 minus 1 and 16 can be written as 15 plus 1. So this is 15 square minus 1. Let us take one more odd number 15 into 17. So this is a product of two consecutive odd numbers. So 15 can be expressed as 16 minus 1 and 17 can be written as 16 plus 1. So here you can rewrite it as 16 square minus 1. So we can generalize this as a minus 1 into a plus 1 is equals to a square minus 1. So product of two consecutive even natural numbers or odd natural numbers is a square minus 1. Without adding, find the sum. So here we are going to use the concept of sum of first and odd natural numbers is n square. So you are adding the odd numbers starting from 1 to 15. So how many odd numbers are here? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 odd numbers starting from 1. So this is 8 square. 8 square is 64. So sum of all the odd numbers starting from 1 to 15 is 64. Here express 169 as sum of 13 odd numbers. 169 it is a perfect square of 13. You are adding the all the 13 odd numbers starting from 1. So let us add it. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, 15, 17, 19, 21, 23, 25. So we have added 30 odd numbers starting from 1. You can count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this all the odd numbers starting from 1 to 25 if you add up that is equals to 169. Now let us take this question. How many numbers lie between squares of the following numbers? That means 15 square and 16 square. So what is that formula we have learned? 2n. Here n is the smaller of the two numbers. So here 2n. n is here 15. So how many numbers are there between perfect squares of 15 and 16? 30. Here, how many numbers are there between perfect square of 97 and 98? That is, the formula is 2n and n here is 97. So 7 into 2 is 14, carry over 1, 9 to the 18 and 1 19. So 194 numbers are there between the perfect squares of 97 and 98. Finding the squares of a number. So if you have to find out the square of a number without doing actual multiplication, then you can use this formula. For example, you have to find out the perfect square of 39 without doing actual multiplication. So we can express 39 as 30 plus 9 whole square. So now we are going to use this formula. So A is 30 and B is 9. So here you will get it 30 square plus twice of 30 into 9 plus 9 square. So 30 square is 900 and here you got 9 into 6. 6 nines are 54 and this 0 plus 9 square. 9 square is 81. Now you need to add up all. So in units digit you have 1. In tens digit 8 plus 4 is 12. Carry over 1. In hundreds place 5 plus 1 is 6. 6 plus 9 is 15. So you have found out the perfect square of 39 without doing actual multiplication by using this formula. Other patterns in square. If you have to find out the squares of the numbers which have got 5 in the units place, then we are going to use this formula. Let us understand how to find out 25 square. So here A is your 2. So you will write down 2. A plus 1 is 2 into 3. A is 2 plus 1 is 3. In this hundreds is into 100 plus 25. So this is 600 plus 25 is 625. Let us take one more example. Say if you have to find out for 35 square. So what is your A? A your here is 3 and A plus 1 is 4. Hundreds plus 25. So 4 into 3 is 12. 1200 plus 25. So this is 1225. Like this we find out if the squares of those numbers whose has got 5 in the units place. Let us now discuss Pythagorean triplet. For any natural number m greater than 1, we have 2m whole square plus m square minus 1 whole square is equals to m square plus 1 whole square. Then we say 2m, m square minus 1 and m square plus 1. These three form a Pythagorean triplet. Now let us take this question. It says write a Pythagorean triplet whose smallest member is 8. So out of these three, you have to assume that 8 is this or this and then start working out. Let us do this question. So let us assume m square minus 1 is equals to 8. So m square minus 1 is equals to 8. So m square is equals to 8 plus 1, 9. So m is equals to 3. So you got the value of m is equals to 3. Now let us calculate the another member of Pythagorean triplet, that is 2m. So 2m is equals to 3 into 2, that is equals to 6. Now here you see the question says the smallest member is 8. But here another member which we calculated with m equals to 3, that is 2m is equals to 6. So this is not possible because 8 has to be the smallest member, but here 6 is the smallest member now. So let us now assume 2m to be equals to 8 and try to solve it. So let us assume now 2m is equals to 8. So m is equals to 8 divided by 2, that is equals to 4. Now let us calculate m square minus 1 is how much? So m value got as 4. So 4 square minus 1. 4 square is 16. 16 minus 1 is 15. So now m square minus 1 is 15 and 2m is equals to 8. So 8 is here is the smaller of the two numbers. Now let us find out m square plus 1. So m square is 4 square plus 1. So 4 square is 16 plus 1 is 17. So the Pythagorean triplets are 2m, that is equals to 8, m square minus 1, that is equals to 15, and m square plus 1, that is equals to 17. So here you can see out of the three numbers, 8 is the smallest number. So 8, 15 and 17 are the Pythagorean triplets. Let us now discuss square roots. Square root is the inverse operation of finding out the square. For you know that 1 square is equals to 1. So square root of 1 is 1. 5 square is 5 into 5, that is 25. So square root of 25 is equals to 5. So you can clearly see it is the inverse process. Here you are grouping two numbers. So 6 square is 6 into 6 is 36. Here we are multiplying two numbers. Square root, here square root of 36. You put it inside 6 into 6. We will group two numbers. So you have square root of 36 as 6. So square root is inverse operation of finding the square. This is the square root symbol. Let us now discuss how to find out the square root of a number. The first method is finding the square root through repeated subtraction method. So here we have discussed earlier in this video that sum of first and odd natural numbers is n square. So that means if you start removing the odd natural numbers from a perfect square, you should get 0. Let us understand with the help of this question. Find the square root of 81 by the method of repeated subtraction. So let us do that method now. From 81, first we will remove the first odd number 1. So 81 minus 1 is 80. Now from 80 you have to subtract after 1, it is 3. So 80 minus 3 is 77. Now from 77 you need to subtract the next odd number 5. So you get 72. From 72 you need to subtract the next odd number, that is equals to 7. So you get 65. From 65 you have to subtract the next odd number, that is 9. So you get 56. From 56 you need to subtract the next odd number, that is 11. So here you get 45. From 45 you need to subtract the next odd number, 13. So you get 32. From 32 you need to subtract the next odd number, 15. So you get 17. From 17 the next odd number from after 15 is 17. So 17 minus 17 is 0. So in how many steps you reached 0? 9 steps. So the square root of 81 is 9. So if you add up all these odd numbers starting from 1 to 17, you will get 81. Sum of all the odd numbers starting from 1 to 17. So here we are doing just the reverse. We are removing all the numbers, odd numbers starting from 1 to 17. So how many steps you are removing? 9 steps. So square root of 81 is 9. Let us now take this question, finding the square root through prime factorization. What are the prime factorization? You need to find out the factors of a number which are only prime numbers. So let us take this question. Is 2352 a perfect square? If not, find the smallest multiple of 2352, which is a perfect square. Find the square root of the new number. So let us first do the prime factorization of 2352 and see whether it is a perfect square or not. So let us do the prime factorization of 2352. This will go by 2. 2 ones are 2, 2 ones are 2, 2 sevens are 14, 2 sixes are 12. Again it goes by 2. So 2 fives are 10, 2 eights are 16, 2 eights are 16. Goes by 2. So 2 twos are 4, 2 nines are 18, 2 fours are 8. Again it goes by 2. 2 ones are 2, 2 fours are 8, 2 sevens are 14, goes by 3. 3 fours are 12, 3 nines are 27, goes by 7. 7 sevens are 49, 7 ones are 7. So these are the prime factors of 2352. So let us express it in the terms of prime factors. So 2352 is equals to 4 times 2. 1, 2, 3, 4. 1 times 3 and 2 times 7. So for this number to be a perfect square, each of these numbers should be in pair. So let us pair these numbers. This is in pair, this is in pair, this is in pair. But 3 is not in pair. That means 2352 is not a perfect square. It says if not, find the smallest multiple of 2352, which is a perfect square. For a number to be a perfect square, all the numbers should be in pair. Here 3 is not in pair. That means if I multiply here by 3, then here also I have to multiply by 3. And then this number will be in pair. So let us write down here 2352 into 3. So here multiplied by 3. Now this side also we have to multiply it by 3. So this 2 I am writing as it is. This 2 I am writing as it is. Then this 3 and I have multiplied 3 here. So I will multiply 3 here also. So now you can see the 3 is in pair and here the 7 is also in pair. So you can see each number is in pair. That means this number, which is a multiple of 2352, is a perfect square. What is that number? 3 into 2 is 6, 3 into 5 is 15, 3 into 3 is 9 and 1 10, 3 to is 6 and 1 7. So 7056, it is a multiple of 2352, which is a perfect square. You can see the factors of this number, they are in pairs. So let us write down the factors of this number. 2 into 2 and here again 2 into 2. Again now here 3 into 3 and 7 into 7. So all these numbers are in pair. You need to find out the square root. This is the square root system. So we are going to take square root on both the sides. Square root on both the sides. So when you are finding out the square roots, we group the numbers in pairs. So here 1, 2 comes from here 1, 2, from here 3 and from there 7. So 2 into 2 is 4, 7 into 3 is 21. So that is equals to 84. So the square root of perfect number so obtained here is 84. So square root of 7056 is 84. Find the square root of the new number. New number is 7056 and we have found out the square root is 84. Now let us take this question. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. Find the number of rows and the number of plants in each row. So what is the question saying? The question is saying that if there are 2 rows, then there are 2 plants in each row. If there are 3 rows, then there are 3 plants in each row. If there are 4 rows, then there are 4 plants in each row. That means if there are n rows, then there are n plants in each row. That means how many total plants are there? N into n. And that is given to you as 2025. So let us assume here, let the number of rows be, let us assume it as n. So if the number of rows is n, the number of plants in each row is also n. That means let us now frame an equation here. N into n is the total number of plants which they have given to you, 2025. 25 plants, you need to arrange it. So you need to find out the value of n here, because that is what you have to find out, the number of rows and the number of plants in each row. So n into n is n square, that is 2025. To find out n, you need to take the square root both the sides. So if you take the square root here, you get n, and you need to find out the square root of 2025. So let us do the prime factorization of 2025. So the prime factors of 2025, let us find it out. First we will divide it by 5. So 5 fours are 20. 2 will not go, so we will put it 0. 5 fives are 25. Now let us divide by 5 again. 5 eights are 40 and 5 fives are 5. 5 ones are 5. Now it will go by 3. 3 twos are 6. 3 sevens are 21. Again it will go by 3. 3 nines are 27. Again it will go by 3. And it will go by 3. So what are the prime factors of 2025? These are the numbers. Let us write it down. So within the square root, 2 times 5, and we have got 4 times 3. 1, 2, 3, 4. So to take it out of the square root, you need to group these numbers, and from this 5, 1 5 will come, from here 1 3, and from here 1 3. So 15 into 3 is 45. So there are 45 rows, and number of rows and number of plants in each row is same. So there are 45 rows and there are 45 plants in each row. There is one more method to find out the square root of a given number, that is division method. Let us discuss this method. I have written down 529. So first you need to place the bar. How are you going to place the bar? You are going to place the bar starting from ones place in pairs. So we are starting from here. So 29 will be under one bar. Then here is one single digit. Still you will place the bar. Now you have to look out for the largest number whose square is less than or equals to 5. So what is that number? 2. So 2 into 2 is 4. Now you need to subtract. 5 minus 4, 1. Then what is the next number under the bar? 29. So you need to bring down 29. Here what is there in the units place? 2. So you need to add 2. 2 plus 2 is 4. You need to fill in here, and the same number you will write it there. You need to fill in here with the largest number, so that when you multiply this new number with the quotient which you are writing here should be less than or equals to 129. So let us try out. 42, here we'll write 2. So here also we'll write 2. So that means you have to multiply here by 2. So 2 into 2 is 4 and 4 into 2 is 8. So let us check out because you have to look out for the largest number. Let us see for 3 now. So 3 you are writing it here, and 3 you have to write it there. That means 43 into 3. So 3 into 3 is 9, 4 into 3 is 12. So you got it equals to 129. So you have to stop here. So you are going to write down 3 here, and number of this bar I am going to write down 3. So here you get 129. So you need to subtract again and you get 0. Now let us see for this question 4096. So here you need to place the bars first from the ones place. So 96 will be under one bar and 40 will be under one bar. Now you have to take the digit which is under the first bar here, that is 40. So which is that largest number whose square is less than or equals to 40? That is 6. Because 6 into 6 is 36. 7 into 7 is 49, which will be more. So here you have to write down 6. The same number you will write down here. So 6 into 6 is 36. Now you need to subtract. So here you get 4. What is the next digit under the bar? 96. Bring it down. Here you need to add 6. 6 plus 6 is 12. Now you need to write down the largest number here and the same number you will write down here in the question. The product should be less than or equals to 496. So let us try it out. For 120, say 3. So you will write down 3 here and 3 here. So 123 into 3. So 3 into 3 is 9. 3 into 2 is 6. So let us see. It is still far. Let us try out for 4. So we are, because you have to look out for the largest number, which you can write it here. So 124 into 4. 4 you are going to write it here. So it is 124 into 4. So 4 into 4 is 16. 4 into 2 is 8 and 1 9. 4 ones are 4. So you got the exact number. So the number should be less than or equals to this. But this number which you are writing here should be the largest number. So that's why we did not take 3. We have taken 4 here. Here it is exactly equals to 496. So we will write down 4 here and the same number you will write down here. So here you get 496. You will subtract it and you get it 0. So what is the square root of this number here? So the square root of 4096 by division method, we got it as 64. And what is the square root of 529? We got it by division method, 23. So these are perfect square because the remainder is 0. If the remainder is not 0, that means it is not a perfect square. Let us take this question. Find the number of the digits in the square root of each of the following numbers. So one way is by placing the bars. So how many bars are there here? Starting from one place, you can see only one bar is there. So that means there is one digit in the square root of this number. You can see square root of 64 is 8. That is a single digit. One more method is there. If there is even number of digits, as here you can see, it's just divided by 2. So how many digits are there? 2. So 2 divided by 2, so it is 1. So like this also you can find out the number of digits in the square root of the given number. So here let us place the bars starting from 1's place. So how many bars are there? 2. So the square root will have 2 digits. Here you see this is an odd number. To find out the number of digits in the square root when the number is odd, what you have to do? This is the formula, n plus 1 divided by 2. Your n here is 3. So 3 plus 1 is 4 divided by 2 is 2. So with this method you also got 2 digits are there in the square root of the given number. Here let us place the bars now. 1, 2, 3. There are 3 bars. That means the square root is of 3 digits. So how many digits are here? Let us calculate with this method. 1, 2, 3, 4, 5. So 5 plus 1 is 6. 6 divided by 2 is 3. See? So with this method also you got the same answer. Whatever method you are convenient with, you can use it. Square root of decimals. Let us find out the square root of 31.36 by division method. So for division method, you need to first place the bars. For the whole part, you start placing the bars from the ones place in pairs. And for the decimal part, you start placing the bars from the 10th place in pairs. Now let us find out the largest number whose perfect square is less than or equals to 31. So that number is 5. 5 into 5 is 25. Now you need to subtract. 31 minus 25 is 6. You need to bring down 36 because that is the next number under the bar. You need to place the decimal point above the decimal point. Here you have to add the number in the units place, that is 5 here. So 5 plus 5 is 10. You need to fill in one number here and the same number you have to write here in the quotient. That number which you are writing here should be the largest number so that the product of this new number so obtained and the product of this quotient which you are writing it here should be less than or equals to 636. So what is that number? Let us figure it out. Let us try out with 6. So here if you write 6, so here also you have to write down 6. So 106 into 6 is 636. That means you can write down 6 here and 6 here. So it is 636. Now you need to subtract. So the remainder is 0. So the square root of 31.36 is equals to 5.6. Find the least number which must be subtracted from 825 so as to get a perfect square. Also find the square root of the perfect square so obtained. So that means it is given to you that 825 is not the perfect square. What you have to subtract from 825 to get it a perfect square. So for that we have to use division method. So the number given to you is 825. So first we need to place the bars. Let us place the bar starting from ones place. So 25 is under the bar and 8 is under the bar. So which is that largest number whose perfect square is less than or equals to 8? That is 2. So 2 into 2 is 4. You need to subtract. 8 minus 4 is 4. The next number under the bar is 25. You need to add 2 here. 2 plus 2 is 4. Now you have to find out this number and the same number you have to write it down there. So let us try out for say 7. 7 into 7 is 49. Carry over 4. 28 plus 4 is 32. Still it is less. Let us check it out for 9. 9 into 9 is 81. 4 nines are 36. 36 plus 8 is 44. So this is more. So that means it will go by 8. So let us multiply 48 into 8 and see. How much you are getting? 48 into 8. 8 into 8 is 64. 8 into 4 is 32. 32 plus 6 is 38. So you get 384. So for 9 it was more, it was crossing there. So it will go by 8. So with 48 into 8 you got 384. Now you need to subtract. So 5 minus 4, 1. 12 minus 8 is 4. So you got the remainder as 41. If it was 0 here, that means the number given over here is a perfect square of the number which you write it here in the quotient. But this is having a remainder. That means this much number is extra. So you have to remove 41 from 825 to get a perfect square. And that will be a perfect square of 28. So let us subtract to find out the perfect square. So the perfect square is 825 minus 41. So 5 minus 4 is 5 minus 1 is 4 and 12 minus 4 is 8 and here you get 7. So 784 is a perfect square and the square root of 784 is 28. So that is the answer. Find the least number which must be added to 252 so as to get a perfect square. Also find the square root of the perfect square so obtain. So here the question is telling you that 252 is not the perfect square. You need to add some number to it to make it a perfect square. After that you need to find out the square root of perfect square so obtain. So to do this we have to use the division method. So let us use the division method. So 252. You need to first place the bar. So let us place the bars starting from ones place in pairs. So the first number under the bar is 2. So here it will go by 1. So you need to subtract now. Bring down the next number under the bar, that is 52. 1 plus 1 is 2. So you need to look out for the largest number which you can write it here and the same number you have to write it down there. So 25 into 5. What do you get here? You get 5 into 5 is 25. 5 to the 10, 125. Let us see for 6. 6 into 6 is 36 and 156. So 156 is more than 152. So it will go by 5. So 25 into 5 is 125. Let us now subtract. 12 minus 5 is 7. 4 minus 2 is 2. So you get the remainder as 27. So here you need to find out the number which you have to add it to 252 to get it a perfect square. Here you are getting the remainder as 27. If the remainder was 0, that means the number given here is a perfect square of the number which you are writing here, that is 50. But it is not 0, it is 27. That means it is more than the perfect square of 50. You know that 15 perfect square is 2 to 5 and you can clearly see it is more by 27. You need to find out what number you have to add to this to get a perfect square. That means that is a perfect square of next number which is written over here, that is 16. So what is the square of 16? You know that 16 square is 256. So how much you have to add? Now if you subtract 252 from 256, you get to know how much you have to add. So you have to subtract 252. So what is the answer? Answer is 4. So if you add, it says what you have to add? You have to add 4 to 252 to get the next perfect square. You see, 252, you add 4, what do you get? 256, which is a perfect square of 16. So they are saying also find out the square root of perfect square so obtained. So perfect square so obtained is 256. So what is the square root of 256? That is 60.